Hi, I'm Burak Öz, a first-year PhD student at HEC Montreal. I'll present our study titled Using Digital Nudges on Analytics Dashboards to Reduce Anchoring Bias. As previously stated many times by other scholars, information systems have become an integral part of today's decision-making environment. We use screens and user interfaces to analyze a situation and make a decision all the time. But research in behavioral economics shows that people are not perfect decision makers. Limited time or limited cognitive resources, whatever the reasons, people suffer from cognitive biases while making a decision, and anchoring bias is just one of them. This study focuses on the anchoring bias and investigates if it can be mitigated through the use of digital nudging. The anchoring bias can simply be defined as making decisions under the influence of first impressions. A real-life demonstration of this bias can be from retailing. Companies are after that consumer surplus in the economic model, so it's not unrealistic to assume that the prices at the store are inflated. So our estimations for the real value of a product often go down from the initial price. And this is why retailers often put price tags that are discounted down to a lower value. In this case, the initial anchoring point could be a convincing number. But more interestingly, research has shown that these first numbers don't even have to be reasonable estimates. For example, in an experiment back in 1997, researchers asked two consecutive questions to the participants. They had two conditions, so one group started with the question, did Gandhi die before or after the age of 9? And the same question for the other group mentioned the age of 140. These numbers are not very realistic estimates, right? Still, the results show that there is a significant difference in the estimations to the second, more open-ended question, which is, how old was Gandhi when he died? The anchoring bias can occur when a numerical estimation is made, and supply chain management is one of the practice fields that suffer from the anchoring bias. Forecasting is a key task in supply chain management, and even though computers can calculate forecasts on a normal day, human intervention may be required in the case of exceptions. And managing an exceptional case in a supply chain is very likely to come with time pressure. And even though they will be updated, the system has a default forecast on the screen. So as you see, a forecast adjustment scenario has all the conditions for creating an anchoring bias. This is a critical issue because an anchored decision not only impacts the decision maker in a supply chain, that distorted information impacts all the forecasts made by their suppliers, and eventually it increases the variance observed by the producer, which leads to an increase in their safety stock levels and leading to a reduction in the efficiency of the supply chain as a whole. Now, the cure that we wish to see working, nudging. It's an intervention that combats or makes use of cognitive biases. Taylor and Sunstein define it as any aspect of the choice architecture that alters people's behavior in a predictable way without forbidding any options or significantly changing their economic incentives. And digital nudging is self-explanatory. It's the use of nudging in digital decision-making environments. These are slight design changes that do not tell what to do exactly, but predictably shift one's behavior. An example of digital nudging could be the colored password strength bars that we see on many websites when we want to register. Notifications can also be considered as an application of nudging. In this study, we focused on two types of nudging. Social nudge, which aims to exploit the effects of social influence among the people to convince them, and educative nudge, which aims to increase the person's competencies by showing them the steps required in their decision-making problem. Based on the presented literature, we investigate the usefulness of digital nudging in reducing the anchoring bias. We propose a research model with two temporal stages, initial use and continued use. In this model, performance refers to how well a person can steer away from the anchor value. So higher performance indicates a lower anchoring effect in this model. Let's first talk about the initial use part. We expect experienced people and people possessing contextual knowledge to be less influenced by the initial anchors. Therefore, we expect higher initial performance from experienced and knowledgeable people. We also suggest that these relationships are moderated by the presence of nudging in their user interfaces. The literature on post-adoption use of information systems shows that the user's behavior moved from a feature exploration orientation to a more goal-oriented feature exploitation behavior over time. Therefore, we can say that the users lose less time trying to figure out the irrelevant functions as they continue using the IS. So we expect them to improve from their initial performance over time. Another side of the post-adoption use is the automatic use of the system. Automatic use may introduce new cognitive biases, but the nudges act as a reminder to reflect on the problem on hand. Therefore, the use of nudges are expected to moderate the relationship between initial and continued performance. To test that research model, we used a between subjects experiment design with three conditions: control, which is no nudging, social nudge, and educative nudge. One of the challenges in testing this model was to create a realistic supply chain management scenario in which the participants needed to make decisions. For this task, we used ERP-SIM. ERP-SIM is a simulation that aims to teach ERP concepts with a learning by doing approach. This simulation already has several scenarios in which the students manage companies and try to maximize their profits. Similar to Karen et al., we selected a scenario in which the participants needed to decide the quantities of the product types to be distributed to three regions. We started the simulation using the same seed values for all participants, so this ERP teaching application inherently provided a controlled environment for our experiment. In the experiments, participants used two different information systems that are already used by companies in real life. One is a dashboard designed on Tableau to analyze the company status and decision outcomes, and the other one is the default SAP interfaces to make their decisions. As you see on the SAP screenshot, participants saw the anchor values on the decision-making interface when they first log into the system. And the nudges. The nudges were shown inside an overlay on the participants' dashboard before the start of the task. Similar to previous studies, we decided to design the social nudge that refers to the manager of the participant in the simulated company. That social nudge listed the charts on the dashboard according to the usefulness ratings given by the managers. On the other hand, the educative nudge focused on providing tips to use the dashboards more effectively. One challenge we needed to deal with is also the reason why we are not in the same room for this presentation. The data collection took part in the summer of 2020. So to conduct the experiments remotely, we used a private user experience research application named Lookback. We started with the pre-task questionnaire to ask mostly about demographics. Then we made the participants watch a brief video explaining their task and the user interfaces of the software to be used. And after the video, they opened their dashboard and SAP interfaces to start doing their task. For the task, we simulated 2 rounds of 10 virtual days in ERP Sim game. In the first round, participants analyzed the default transfer quantity decisions and their impact on the company using the dashboard. Participants had 8 minutes to complete this analysis and adjust their initial forecasted quantities. After task 1, the simulation is advanced to the next 10 days and participants made the same decision using an updated dashboard showing the outcomes of their previous round. So participants started at the same game state in the beginning of task 1 and they continued from their initial decision in task 2. After the tasks, we finished the session with a post-test questionnaire and an interview. A session took approximately 1 hour, and participants received a gift card in the amount of 30 Canadian dollars from an online retailer. And the measurements. We used two experience dimensions, each reflected by a one-item self-report. Experience in the domain measured the participant's level of experience with using any ERP software, and experience with the technology is whether the person played an ERP sim game before. Knowledge was measured by the count of correct answers to a set of true-false questions from textbooks in supply chain management, economics, and forecasting. Anchoring measurement is calculated using the participant's decision on ERP sim. We calculated the Euclidean distance between the participants' decisions and the initial anchors and used that distance as a reverse measure of anchoring. Okay, the results. First of all, the good thing with remote data collection is that we were not bound by the geographic distances, so our participants were residing in different countries: Canada, France, Turkey, and United States. We collected data from 61 participants, and their distribution among the three conditions turned out to be uniform in terms of their education, knowledge, and experience levels. We used two independent regression models to test our initial hypothesis. The first model you see here focused on the initial use stage of our conceptual model. Results only show support for H1, which was about the impact of experience on the extent of anchoring. In the analysis of continued use, we found support for the hypothesized relationship between initial and continued anchoring correction distances. However, the results do not show a support for the hypothesized moderation effect of nudging here. Although using anchoring correction from the first round was consistent with our development of hypothesis, that approach may also ignore some potential sources of noise. For example, participants have not seen the outcomes of their decisions in the first round. So, to answer our research question, we conducted a post-hoc analysis combining the initial use part of the model with the most endogenous variable, anchoring correction after continued use. As the previous model also suggested, results of this analysis show a positive effect of experience on the anchoring correction. Moreover, the results show a positive interaction effect of educative nudging and knowledge on the anchoring correction. The results on this page are not on normalized values, so the interaction term here can be multiplied by a knowledge measurement that range between 1 and 7. Therefore, we observe a crossover interaction between knowledge and educative nudging. To conclude, in this study, we brought digital nudging to the workplaces to improve employee performance and tested its usefulness. We observed social nudges as a nudging example that did not work. Since the simulated task had an imaginary company, our social nudge mentioning the participants' co-workers in this fictitious scenario may not have had a real social impact. So we conclude that this result may be different in a field and could be investigated further. Our results show that the decision makers with higher domain experience are less likely to be influenced by the anchoring effect. More importantly, we see that using a familiar IS in a different environment for the first time means that there is a higher possibility of anchoring. Our post-hoc analysis also shows that an educative nudge can be used to increase users' performance if the user possesses contextual knowledge. Otherwise, educative nudge will have a negative impact. So, to answer our research question, considering that an employee is already supposed to have contextual knowledge, managers can consider including educative nudges in the analytics dashboards. Thank you for listening. This study was an outcome of a highly engaging collaboration, so I want to thank my co-authors Kevin Tran Nguyen, Konstantinos Korsaris, Jacques Robert, and Pierre-Majoric Légy. I would also like to thank Answer Prompt and ERP Sim Lab for the financial support. And finally, I would like to thank the Tech3 Lab and ERP Sim Lab teams for the technical support.